Hi everybody, just want to do a review of a single event probability, but using this frequency table that they give you. So just a reminder about probability, it's always got to be a fraction. It always has to be a probability. When you have a probability, it's always going to be a number between 0 and 1. It can't be beyond 1 or negative. That would make no sense, okay? So the other thing is, you have a disjoint situation. That's like a situation of R. That disjoint means they have nothing in common. So nothing in common. So if you see that situation will come up in the examples below. But if it's not disjoint, so they have something in common, and that would be this and thing right here. Okay, so that is referring to and. Another word for that would be both, and that's over here. This is both and. And that all seems very trivial, like what is this, and these weird little formulas. The formulas are very helpful, although you can answer a lot of it conceptually. The formulas will help you when it gets more complicated, so it's very important that you are aware of them. The last thing, and the one I want to focus on at the end of this, is the conditional probability. And that is when they give you a situation of given. Like they say, what's the probability of A given B? Depends on something else already existing. And the way you do that is you take the probability of both, that's like the and the intersection, whatever, over the probability of what it's based on, the bottom one, right? Okay, all of that's wonderful, but you really just need some examples to really get it, I believe. Okay, so here you have this situation. A survey is conducted among students. There are 50 of them, and they are randomly selected and asked questions of what they prefer, dogs, cats, or some other pet. So the table gives the results. So we're going to be analyzing this. So first things first. What is, stay put, okay, what is the probability of choosing a girl? Notice that's all they said, there's a girl. And you're looking at this table, and the table has the totals as you see on the bottom. So really the only things we have going on, like this is the main part of the information, right? And the totals will help us. This is the total of all the people that were questioned. There's 50 total people questioned. And the little mini totals on the side, that's the total of on here, the 28, that's the total of all the girls because it comes from girls. This is the total of all the boys. Down here, this is the total of all the other pets. This is the cats and the total of people who picked a dog. Okay, so those are the totals. So when they say what's the probability of choosing a girl, I'm going to highlight what I would focus on. I would go to the girl column and I would pick 28 out of all the people asked, 50. That's the probability of choosing a girl. Now, they will ask you, and that's it. So what is the probability of choosing a person that prefers a cat? Now they're talking about preferring a cat, and that's it. So I'm going to look at that, and I'm going to go, well, I'm not going to go horizontal. I'm going to look at the cat column. That would be right here. All right? There's the cats, people who are the girls who picked cats, the boys who picked cats, ultimately all the ones, because they weren't specific. They didn't say boy or girl. They just said cat. So basically, that is, I'm going to write it out like this. I didn't do it the last one. I'm going to do it this time. The probability of cat, I'm going to say, just like that. And that is 15 out of 50, right? And this one was the probability of girl. I like to write it out like that. Oops, girl. So then that's 28 out of 50. Please note that 28 out of 50 is one answer, but I could also write that answer as, whoops, I don't want that. I can write it as 0.56, right? That's another answer. Or I can write it as 56%. Any of these answers are totally fine, and you should be aware of them as multiple choices. So now we're on preferring a cat, right? So the probability of preferring a cat we were thinking has to do with 15 out of 50, or the other answer can be 0.3, or the other answer can be 30%. How am I getting this percent question? I wonder. You know, some people, I know you might be able to figure out like the 0.3, like I just take the calculator and I go 15 divided by 50 and I get 0.3. But how do I get 30%? So just to remind you, what I do to get that as an option is I take my 0.3 and I multiply it by 100, and that will give me my 30%. That's how I did that. In case you were wondering, that's what I did. And I will be going over all these. So all these answers are good. This is good, this is good, this is good. Okay, so now the last one. Look at this one. This one is saying, what's the probability of choosing a girl that prefers a cat? And it's not a make up your mind kind of thing. This is specific. This is probability of girl and the and symbol, we use this, and the probability of a cat. All right, so then that would be cat. So that is the intersection. We only have one event. This is only one event. So you just have to find which one is both. Okay, both girl and cat. I'm just going to erase here, clean it up a little bit, and find out where that, well, actually, I could have left that because that's exactly what we were looking for. We were looking for which one is both. So here we have girl, here we have cat. Do you see where they intersect? Are you looking at it the way I am? It's right there. That's the one that's both, the intersection of the both. So that would be 6 out of the whole total, 50. And 6 out of 50, that would be the same as saying, if I divide that in my calculator, I would get 0.12. Or I can say that if I multiply that by 100, if I multiply by 100, I would get 12%. Any of these answers are perfectly fine. Or a fraction of this one. This one, by the way, could be reduced to like 3 over 25. Any of these answers are good, okay? So I just, some of the things about probability is I like the decimal or the percentage the best because you don't have to reduce anything, okay? All right, so that's how that goes. You just go for and, it's just for which one's both. It's so simple. Okay, let's look at this other one. Okay, what is the probability of choosing a boy that prefers the other pet? So they want boy and they want other. They didn't say or, they want both. So this is the same as probability of boy and, so that's and, the other. So I'm going to do my little focus here. Boy, okay, and other. I'm going to zone in on that intersection, and I'm going to say 3 out of, you thought it, 50. That would be my total, because that's still my total, right? That's still my total, grand total, you can call it. Okay, so that's the same as 0.6, which is the same as 60%, right? Nope, I was kidding. That's 0.06, which is the same as 6%. Okay, so it's a very small number, right? I was about to say it seemed too big. Sorry, miscalculated. Okay, so now what is the probability of choosing a person that prefers a cat or a dog? Okay, now we're getting to something a little more complicated. That's a 2-letter word that really complicates things, the word or. So the probability of, for or, this is the probability of cat or dog, right? So that would be, thank you. So that would be like this, the or symbol. So the probability of cat or dog, now I'm going to use my formula for that. So I'm going to write down the formula here. The probability of A or B goes like this. It's the probability of A plus the probability of B minus the probability of both, okay? I know you can't pick both cat or dog, like you can't pick this both, so, I mean, but I still like to put the or in there. I like that formula. So what's the probability of a cat? So the probability of cat was coming down this way. So it's 15 out of 50. What's the probability of a dog? That's this one. So it's 22 out of 50. What's the probability of choosing both cat and dog? That option was not available, so that's 0 out of 50. And so that's the one where it would be considered the disjoint, like I had up here at the top. That's a disjoint situation because they can't happen. They can't both be. But you know, you can just write it in a formula. It doesn't matter. So ultimately, for fractions, when the denominators are the same, you can just add the top. So then that's 37 out of 50. And 37 out of 50 is about I think I added that wrong. Cat was 22. Oh yeah, no, I did that right. And that one's 15, right. So then that's 37 out of 50. So 37 out of 50, I think is 74.74 or 74%. Okay, so that's the other option. Now let's see what this other one. What is the probability, I'm going to pick a different color here. What is the probability of choosing a boy, or there's that or word, or a person that prefers a cat? So the probability of boy or cat. Okay, so that would be my formula. That's the probability of a boy plus the probability of a cat minus the probability of both. Remember, both is the intersection. I'm going to erase this so I have it fresh again. So let's hear it. The probability of a boy, that's boy, follow it, 22 out of 50, plus the probability of a cat, follow it, 15 out of 50, minus the probability of both. That is the intersection of the two. So that would be here, where they intersect. 9 out of 50. So altogether, that would be 37 minus 9, right? I have that right. So 37 minus 9, I think it's 28 out of 50. All right. So 37 minus 9. Yeah. So, oops, where'd it go? So, all right. So 28 out of 50. So that's 0.56. Or 56%. I'm just going to leave it like this. Any of these answers is fine. Okay. So what is the probability of choosing a person that prefers a cat given he's a boy? Okay. So now we did the or formula. Now we're going to do the conditional formula. Okay. So I'm going to get a new color for that. All right. So I'm going to erase and let's just see what we're talking about here. So probability of choosing a person that prefers a cat given it's a boy. So that would be probability of cat, and this is the symbol for given. Actually, it's more vertical. So I'll put it like this. It's more like vertical. So given is a boy. So that formula, if you remember, is you do the probability of both over the probability of that last one, boy. So the probability of both boy and cat, so boy and cat, that would be here, 9. 9 over 50 divided by 22 over 50, which at this end is just 9 over 22. Okay? So 9 over 22 is just 0.409. So that's about 40.9%. Okay? So now let's try the last one. Oh, the last two. What is the probability of choosing a person that prefers a cat given she is a girl? Okay. So here we have another given question. So it's the probability that she prefers a cat given girl. So that's the probability of both. That's the intersection over the probability of girl. So the probability of both, so that would both be the intersection of cat and girl. You see that? 6 over 50, that's that probability, over the probability of just a girl. So that's this whole thing, that's the end of this. This is just girl. 28 over 50. At the end, the 50s cancel, you really just get 6 over 28. Okay? So 6 divided by 28 is 0.214. So that's about 21.4%. And the very last one, let's see it. Of the people that prefer a cat, what is the probability of randomly choosing a girl? This time they're saying of the people that choose a cat. That's our given, you know. They just didn't write the word given. So they want to know what's the probability of getting a girl, of choosing a girl, given that you have somebody who prefers a cat. That's how that works. So that's the probability of both. So both cat and girl, we did that already. 6, it's the same number, 6 out of 50. But this time the denominator is the probability of a cat, which is 15 out of 50. I got it right here, that's cat. So it's 15 out of 50. So this ends up being 6 out of 15. And 6 divided by 15 is 0.4, which is the same as 40%. So all in all, you really just need to know what probability of A and B means, like the both. It's very important to know that. And also the probability of A given B. That's the probability of A and B, like we just talked about above, over the probability of B. And the other important one is the probability of A or B. The word or when they give you that, which is the probability of one plus the probability of the other minus the probability of both. Okay, so just knowing those things are really going to help you. So here's the neater version of them. I hope this video helps and you have a good day.